Hi, Bill. How are you doing today?
Hey, Robin, I'm better for seeing you. How are you?
I'm fantastic, thank you. It's the new day of a new quarter. So
It
all of the
is.
sales folks are getting excited to reach out and talk to me again. The grind never stops, just like how security never stops.
Indeed.
What happens when you stop practicing security?
Bad things can happen, Robin. In fact, I guess my own personal physical next-gen anti-malware dropped, and I ended up catching a virus over the past weekend, so should have been taking those vitamins, keeping things running. If I sound like I'm underwater, that's why. Um, gotta look after that security all the time.
Well, there's a layer of security between you and I, so that prevents lateral movement at least. But hope you
That's
feel
right.
better. Hope you feel better soon.
Thanks, man.
So, what do you have for me today?
Robin, I wanted to talk about something old that has become new again. And really, this was precipitated from a conversation that I was having with a couple of customers and a partner. Actually, we were in an event and was sharing some of the things that our solution can do. And this particular customer raised their hand and they said, "Well, we see that you protect against DGA. What is DGA?" And I thought, wow, I thought everybody knew what DGA was. But again, we can't assume that something old is new. So I thought what I would talk about today is domain generating algorithms, or DGA. How does that sound?
That sounds fantastic, and it's a good reminder about the curse of knowledge. Once you know something, it's very hard to imagine a world where you didn't understand it. And for many security practitioners starting their journey, things like DGAs might be a complete mystery. So, yeah, let's talk about DGAs. Educate me, Bill. What are
Yeah.
they?
Yep, will do. And you're right. A lot of folks who are starting the journey now may not realize that this is something that's been around for quite a while and therefore may not get exposure to it. So let's talk domain generating algorithms. Where we really first saw this on a large scale, Robin, was back in 2008. So if we kind of wind the tape back, that dates me too when I talk about rewinding tape. We saw something significant take place on the Microsoft Windows platform that eventually came to be dubbed as the configure worm. Now, for our German speakers, my apologies, that's just what it ended up getting named. But the configure worm was a worm that did specifically target that platform. And part of what this worm did is it established communication with a command and control server. Now, most folks today know what a command and control server is, but what was so unique at that time is that the authors of Configure knew that if they simply communicated with the same command and control server, right, reaching out to a particular domain in order for it to not only command the Configure worm, but to send payload to it, that very soon we would understand how to block it and it wouldn't be effective anymore. So they implemented a domain generating algorithm so that the command and control server literally changed all the time. A lot of times we'll refer to this as fast fluxing or domain fluxing. So what essentially happens here is that both sides of the equation, the configure worm itself, as well as the command and control server, need to be able to rapidly change its domain for the command and control server so that trackers have a hard time doing that. Now, the trick here, Robin, is how do we keep them in sync, right? How do we know where the command and control server is? How does the configure worm know where to reach out? So the way that we do that is we have to develop an algorithm that both sides are aware of, but that is not communicated openly so that the two can actually plug into each other. So following me so far, are we good to go to dig in?
I'm with you so far. I'm thinking of this like I want to log into my banking, well, my web bank. I need to open an application with a timer and a counter. There's a timer and a counter at the bank side. I have something on my side. They're synchronized up, but no other party is aware.
That's right.
Am I following along?
You've got the absolute essence of it, and it's making sure that both sides are in sync. So let's give the recipe for a domain generating algorithm, similar to how we did with ransomware last time. So step one is you have to have a top level domain. If you're using a domain generating algorithm that is constantly changing the domain, you need a top level domain that's firm that can host your constantly changing domains. Now, the algorithm will then generate domains to be registered with that higher level domain. Now, the first thing you might think about here is, can't that get expensive, right? If you've ever registered a domain, you know that that can be rather costly. So one of the things we have to look at first is, do we have a registrar that is reasonable from a pricing perspective, that we can keep creating these pseudo-randomly generated fast flux domains? So the algorithm has to do that. It has to be something that we can do for a reasonable expense. And then further to that, the algorithm will typically generate these random domain names seeded by some time-based variance. So what does that mean? That means that in computer science, there is no true random generator, right? You have to seed it with something. And in our case, we will seed based on something that is, it's a time-based variance. Now, that could be something as simple as a clock. It could be, what's the date today? That's going to be the seed for the random number generator on both sides of the equation. The problem is, clocks are very predictable, right? We know what the date is today. We know what the date's going to be tomorrow. And so all of a sudden we can predict what these domains may be. So time-based variance can be on a clock, but they also can be on things like, well, I don't know, pick your favorite social media platform like Twitter. What are the trending topics on Twitter at this hour? Since both sides can determine that, they can use that as the seed for this randomly generated domain. So it's pretty hard to predict, right? So much better in terms of a domain generating algorithm. Now, in the end, this is what makes building deny lists very difficult, right? It's hard to deny domains that are going to rapidly change and are going to be based upon some pseudo-random generator on both sides of a domain generating algorithm. So that really was the intent behind the threat actors, was, first of all, make it inexpensive. Second, register it with the top level domain so that it bypasses any of the typical signatures that say, this top level domain is dangerous. And then third, do it in such a way that is so unpredictable that it would be very difficult for even threat analysts to identify, hey, there's something going on here. So the big question is, Robin, how do we protect against this?
While working with a previous company or customer as a contractor, their answer was to blacklist the entire internet. Everything was denied, and they would only allow specific URLs. So if you want to go to Google, you would go to Google once, you would be blocked, and then the IT team would allow Google. You want to go to Facebook? Well, it's the same. And over time, they built up an index or an array of all approved and allowed websites. Is that the best way to defend against DGAs?
Boy, it seems practical enough until you actually get into the real world and you try to manage that. I mean, that is a management nightmare to try to take care of that. Plus, we have to recognize that the speed of business is such that we cannot wait on what is essentially a manual process, right? It just is not practical, especially if, as an organization, you make a decision to adopt a stronger security posture. You're going to have to plan this all out ahead of time to make that transition as smooth as possible. It's just, and it sounds great on paper. It sounds good scholastically, but in the real world, very, very difficult to do these default denies with an allow list. So how do we actually do this? How can we make this happen? Well, the good news is we can bring machine learning to bear on this. Now, we love to talk about machine learning, and hey, everybody likes to say we have it. Well, how does it actually work? Well, machine learning is able to begin to identify not only those patterns, but they can even identify the behaviors. Why are we getting these strange changes and requests for domains, especially when machine learning can avail themselves of natural language learning models? Boy, isn't that timely, Robin. They're able to learn that this doesn't make sense from a dictionary perspective or from a natural language perspective. These strange domains that we're trying to reach out and contact, or they may even be able to identify patterns in the words that are being used in these fast flux domains. So machine learning has been proven north of 99% effective in identifying these fast flux domains and helping to mitigate that. And then, of course, you can add some other behavioral characteristics. What kinds of responses are we getting to NX domain requests? Or, what is the who-is information behind these domains? And then, of course, you can even protect yourself using some passive DNS to make sure that some of these things don't get resolved. So a little technical, but being able to protect against domain generating algorithms, very important. It is something that has been around for a long time, but actually understanding what it is, why it's used, and how we protect ourselves, very, very critically important. And, the good news is we are able to bring that to bear using not only machine learning, but boy, there's some really exciting things right around the corner too, Robin.
Absolutely. So I like the fact that you brought machine learning up. It's the current buzzword. It's the hot topic. Every company say they do machine learning or artificial intelligence.
That's right.
But in reality, it's because it's a necessity. The speed of resolution, the speed of identification. If you look at a traditional secure web gateway or an internet firewall, generally that's 1 to 3 different pieces of information they would piece together to have a contextual decision. But with machine learning, you open the doors for rapid parallel processing of many different data points, all to aggregate into one decision. And as it learns, as it gets better, as it grows, generally it doesn't just look at your data, it looks at other data in the model. It looks at indications of user intent. It looks at time. It looks at the heuristic, it looks holistically even at the entire transaction to determine whether or not things should be allowed or disengaged. So
You're right. Yeah, 100%.
Machine learning excites me and scares me simultaneously. And I think that's good. If you're not scared about your technology, you're too slow.
And it really is that way. That's sort of why I like to get out of the old school mentality of the good guys and the bad guys, right? Or the threat actors, right? And let's think of it more as those who come from a red team mentality and those who come from a blue team mentality, right? You can almost think of it that way because it really is a cat and mouse. When you see things like language learning models, and we get frightened of those things because we say, boy, what could the bad guys do? But you know what? The good guys can use that too, right? Mm-hmm. So it really isn't bad or good. It really is kind of that red team, blue team mentality. And if we adopt that, we will understand that this really is kind of an endless, well, I guess we would call it a ping pong game, right? It's a constant volley back and forth. This technology is developed. It's adopted by the other side. It evolves. It's exciting. If you really think about it, it's very exciting. The key is, are you paying attention? Are you utilizing the technology? Are you sharing context? Are you staying ahead of the curve as much as humanly possible? And that's being willing to keep your thinking open and be able to take in these things that not only are new, that are happening, but also look back in time, because an awful lot of instances occur where old technology, old approaches, old behaviors are used. In fact, they most often are, because it's hard to change behaviors. Those are what tend to get used, and that's what tends to develop the latest thing in the news. So, here we are, and boy, we've got something that hit the news, and of course, all the hair pulling and the jumping around starts, and yet it's something that has been around for a long time. So again, something that was old became new, and I think you're going to tell us a little bit about it today. Why don't you dig in for us a little bit, Robin?
Yeah, sure. So, Bill, I don't want to date you, but what were you doing 10 years ago?
This.
It's a constant.
I guess it does date me, right? Yeah.
Security is a series of tools. If you have a hammer, you can use that to break bones or build bridges. It all depends on the intent. But 10 years ago, a CVE was released, a vulnerability and exploit known as old 2013-3900. Now, this vulnerability, in short, would allow people to sign Windows executables with dodgy bits of code that could be executed and bypass items. Mm-hmm. Now, that was 10 years ago. And Microsoft released a optional fix or optional patch that has been available since, I think, 2013 but it's optional. Lots of people haven't enabled it. But this week, the company 3CX have kind of come into the fire due to a supply chain attack. Now, Bill, do you want to educate folks? Give us 3 sentences. What's a supply chain attack?
Well, let's think of it in the physical world first, in actually building products. A supply chain is an original equipment manufacturer providing something to someone down chain who then wraps their pieces around it and then releases it. And because it's trusted from the end point, it automatically trusts everybody behind it. The sentence to translate over to here is from a software perspective. Because we trust what's happening up the chain and that gets signed as trusted, then we automatically trust it down the chain. And there is the flaw in our thinking, because if the compromise happens upstream and we simply pass it through, we gotcha.
We gotcha. And that's where Implicit Trust comes in. Now, on March 29th, this supply chain attack was identified, and 3CX, for those who are not aware, they're a VoIP company, voice over IP. Now, we have traced the initial attack, and we believe it is a nation-state attacker. Currently, things are indicating North Korea, but it's still to be defined.
That's right.
And effectively, this 10-year-old vulnerability has caused huge implications to 3CX operations. Now, this vulnerability, this CVE, it allows executables to be legitimately signed by Microsoft. And I say legitimately in air quotes, as far as all of the file inspectors and your hash checkers have verified, Microsoft has said this is legitimate. And it's actually being used not to just prank somebody, it's actually being used to distribute malware. So threat actors are injecting code, they're signing bad code through a legitimate Microsoft certificate signer, and by the time somebody downloads that file and opens it, malware starts propagating onto their network. Now, the thing that scares me here, Bill, is this isn't the first instance of this happening this year.
Right.
Now, if we look back, I think back to January, there was a company called Zloader or ZLeader, depends if you're Z or Z, American, British, and there was an infection campaign that happened there. So it's not the first time this has happened. And if we look back just over the past 6 months, there's other big supply chain attacks which have had very similar patterns.
Right.
And the biggest ones I can think of are Kaseya. That was the big one where everything fell apart, as well as the SolarWinds vulnerability.
Of course. Yeah.
Now, if I'm just focusing on the 3CX case, let's get a little bit nerdy. The signed files were actually DLLs, distributed linked libraries. And these linked files, these DLLs, were actually used to connect to a C2 server, a command and control server, as we've mentioned before. Once connected to this command and control server, and we don't know whether or not they're using DGAs or if it's a static URL, it could be either, depends on how you configure it.
Right.
Once it's connected to the CNC, it actually reaches out to a GitHub repository and downloads that information stealing malware. Right. So as far as everybody's concerned, the application is working as needed. They're going to a legitimate GitHub file and people are trying to access data. But unfortunately, the Electron desktop app, the product of 3CX, is causing data exfiltration, it's causing encryption, and before you know it, those 6 E's of ransomware are back on your door, and exfiltration comes a-knocking. So this is scary for a lot of people. They're going to a legitimate vendor. They're downloading a legitimate piece of software. All indicators are saying that everything is fine. The software is working. The software is deployed correctly. It comes directly from the trusted vendor, but there's malware.
Mm-hmm.
So I wonder, Bill, how would you protect against this? What would be your first step to protect yourself?
Boy, we talked about this, and the inherent trust is really the issue. When we were talking earlier about domain generating algorithms and trying to build this default deny and then a massive list of things that are allowed, GitHub may be one of those things that you would allow. Threat actors are really, they're intelligent. They realize that low reputation domains and so forth, that we're watching for something like that. So they are able to reach out to legitimate repositories, pull this malware down. And part of the reason they can pull this malware down, and this happened back in Conficker as well, is they will encrypt that malware so that typical signature-based engines don't catch it. They don't notice it, let alone using things like polymorphic malware, which is a very real thing, right? Malware that constantly is changing and therefore defeating signature-based analysis. So, and lastly, I would say that from a security posture standpoint, we have an awful lot of security organizations that look at things like TLS inspection, right? Typically, when we reach out to the internet to pull down malicious payload, we're gonna tunnel that out using TLS, and an awful lot of organizations say, gosh, it's just too hard to do TLS inspection. Organizations have made it difficult with things like certificate stapling. Again, we're getting a little geeky on this, but all of these things, how do we protect against that? All of these things really come into play here, right? How do you defeat something that is apparently trusted, right? Well, one of the key things is you're going to have to look at the endpoint where that trusted, quote unquote, trusted payload landed, and you're going to have to begin to examine behaviors from that endpoint perspective. And there's multiple ways that you can do that, whether they're connected to some sort of inspection or you are doing endpoint protection. But ultimately speaking, we do have to look at things from a behavioral perspective. That's the way we're going to have to protect because, again, legitimate certificates, legitimate sites are being used to be command and control servers, to be malware repositories, and that's how they're actually infiltrating, getting down the kill chain and acting on objectives. So how to do it, Robin, I wish I could answer it in a sentence, but all of these pieces need to come to play with shared context to be able to analyze this and ensure that this is not what's taking place.
Well, I can summarize it in a single sentence.
I'd love to hear it.
If you were a Cato customer, you would have been protected. There we go. Nice and easy.
That's a true statement.
I know we're not meant to be pushing the agenda, but if I look at the attacks, that's each of the step of the attack and how Cato is protected. Now, first of all, the file has been downloaded. It's a legitimate file from a legitimate vendor. So, of course, it wouldn't trigger any internet rules or IPS rules because it's a legitimate variable. However, once something is tried to access the C2 domain, the command and control domain, we automatically detect that through our internet firewall or through our IPS. Either way could be detected. And by default, yes, in case anybody's wondering, Cato does protect against this 3CX. We have for a long time.
That's right.
But as soon as we identify the malicious domain, that's automatically blocked. That's a default out-of-the-box category, no configuration needed. Cato would automatically identify and block against that. So that's great. Now, after that, we have our intrusion prevention system, our IPS. So all of the payload servers that have been identified associated with this vulnerability have already been domain blocklisted. So it means that no information in, no information out. This is complementary to the firewall rules that we already have in place, and it's not dependent on them being enabled. So either way, there's another layer of protection. There's another layer of security.
That's right.
We also have anti-malware protections. Now, all associated 3CX Trojans, the known signatures, the defined signatures, have been added to a global block list, so you don't have to worry about somebody bringing in the file through an unsecured endpoint or bring your own device. So as soon as somebody comes into an office, you're still protected.
That's right.
And for the customers that we currently do have under the Cato banner, we have constant proactive monitoring. So we've identified several accounts that would be vulnerable to or have been attempted to be attacked through this exploit, and we've contacted those customers and let them know who, what, where, when, and why their vulnerabilities are. So if you have a MDR, a Managed Detection and Response Security team, especially with a single context, it makes it a lot easier to understand the overall threat impact and the overall lay of the land. So through using these multiple layers of security, all through a single platform, all incredibly easily deployed for your users, you can kick back and this 10-year-old vulnerability, you don't really need to worry about it. Sure, you should still patch your Windows servers. We don't get rid of the underlying vulnerability. That's still there. But having Cato in the middle protects you every single stage of the way. And hopefully, Bill, your immune system will keep you protected over the next week or so as you recover from this ever-developing virus located within your core.
You bet.
Okay, well, until next time, Bill, you stay well, you get better, and stay safe out there.
Thank you, Robin. You too.